Hi, welcome to Fun Videos. This is DC here. This is the second video on Mifare application directories. That's the MAD. So this is the continuation of the previous video. In this video, I'm going to show you a little more about the way the data is stored in Mifare Classic 1K. We're going to see in brief what these MAD sector bytes are. And also I'm going to show you the GPB or the general purpose byte that is stored in the sector trailer. And we're also going to see what happens to the tag when it is made read-only. And also I'm going to show you the MAD structure in the Mifare 4K. In my previous video, I've showed you how to use the software called GoToTags Windows app. So in the last videos, I've showed you the way to format the Mifare classic tag, and we also wrote one single NDEF message, that is the message of type website URL. So what has happened just now is, as soon as I place this tag on this on my reader writer, automatically the browser opened with the URL stored on the tag. Now this is happening because of the way the GoToTags software works. So as soon as it reads the tag, it reads out or extract out the NDEF message, and it automatically opens the browser. So that's really a good feature to observe. So I also made one brand new tag, and you can see here this GoToTag software shows what type of tag is it, and also the UID of the tag. It says it's a Mifare Classic 1K, and also it says it's not formatted. So probably now we have to format this. Try one more. Now this one is the Mifare Classic 4K. You can use either Mifare Classic or the latest version like Mifare Classic EV1 4K. And you can see here, so I have already formatted this tag with the MAD format, and there are no records in this cardette. Now here, so this tag has got one NDEF messages of the website, and it is because of this message the software is able to open the browser with this URL. Now this is a brand new tag as well, which says formatted. Now what I wanted to show is probably yeah. Now as you can see here, so this is a formatted tag, but I have made this as a read-only. Now you have to be very careful when you make the tag read-only. It's like a one-way operation. You cannot undo it. Now the way you do this tag read-only is, I'm going to use the one which is not set to read-only, and you try to write NDEF message. It's not, sorry, I don't want to format that. Yeah, one more nice feature which I want to show you here is you can also unformat the tag. So if you click erase tag, you can see it's erasing. So this has removed all the messages on this tag. Now if you place it again, it says it's formatted but no messages. Now I'm going to write a message, NDEF message. So let that be the URL to my website, and the title is Now if you record this encode tag and if you choose this button, make the tag permanent read only, I'm going to place. Okay, it says the tag is read only. Probably this is not the tag I want to use. Okay, now the tag is encoded. Now we're going to see what exactly has happened into all the sector access rights when it is made as read only. So I'm back into this software. So I'm going to activate. I'm going to read. First I'm going to read everything which has a key D3F7. We know that in last video I showed you this is the key used by all the NFC sectors. I'm going to read. And also I'm going to bring the content of the MAT sector, which is sector 0, authenticate and read. Okay, so this card is made read only, and the difference between read only and the not read only tag is with the access rights. So by making this tag as read only, the access rights have changed to all the data block have changed to 2 and the sector trailer has changed to 6. And if you look at this access rights bits here, 2 corresponds to, if you look at the data area here, because this the block 0 is a manufacturer block, which doesn't matter what access rights you got, it's always read only. So take for example a block in sector 1. Now access rights 2 means it can be read, or it can be read either using key A or key B. So you cannot write and do any write, you can't do any write operation. So this is the way you can make a block as a read only. If you go to the sector trailer, so I'm going to refer to the top table here, which is set to 6. If you see the value of 6, the key A, you can't do anything. You cannot change the access rights and you cannot change the value of key B. So this is how you make the sector trailer read only. So nothing can be changed in either in the data blocks or in the sector blocks. Now I'm going to show you what is the content of this MAT sector block, MAT sector, which is the sector 0. I'm going to cover all these bits and bytes in detail in my later videos. So here the thing that is that's worth mentioning here is, see, we have got in a Mifare Classic 1K there are 16 sectors. So there are 16 sectors altogether, but the first sector is reserved for the sector 0, the MAT. All the remaining 15 sectors are used to store the NDEF messages. That's why they're called as NFC sectors. So starting from the block 1, the first byte here, the first byte, so this is the byte reserved that stores information about the distributor of this card. And the second byte, this is the checksum, and from the third byte onwards, this is called as the application IDs. So each of these sectors you can think about like having a separate application. So these 2 bytes are called as AID, application IDs, that corresponds to sector 1. The next 2 bytes corresponds to sector 2, and next 2 bytes correspond to sector 3. So these are like a pointers from here to the corresponding sector. Now I'm going to cover in detail about this. Just is worth knowing a little bit about that. So if you look at the documentation, it tells you exactly what are this the AID corresponds to. I'm going to take the example of the AID. See, all these AIDs are the same. It's 03 and E1. So 03 means, if you look at this documentation here, so 03, if you go to the end of the documentation, so these are some of the standard codes. So you can think of the 2 bytes consisting of a cluster code and the application code. So 03 corresponds to somewhere here, it's a miscellaneous application, and after that you can see this is some kind of a category of the application that's stored in the tag. So if you come across, say for example 1 2 in the first byte, it means this card to do something with the transport. So likewise, these are some of the standard built-in commands, built-in code, sorry. And the other byte, you can specify whatever you want. This is like application ID. So by looking at the first 2 bytes, you can identify which sector will have the data for the application. So the one more byte which is worth mentioning in this video is the GPB, the general purpose byte, which is the byte B9. So if you come across this C1, so this tells you what type of format the tag has. So C1 corresponds to MAD1, C2 corresponds to MAD2, and probably C3 corresponds to the MAD3, which is the structure stored in the DESFire tags. So we're going to go and study this in detail in my future videos. So next I'm going to show you the structure, what's the return when you format a Mifare classic 4K. I've already placed a Mifare classic 4K that's formatted using the GoTo tag software, and we know that when the tags are formatted, we have to use the key, the NFC sector, to read. Sorry, I have to give the read here, read entire tag. Okay, so you can see here, we have read sector 1, and we are read up to the last sector, the sector 39. However, this key is not able to read a sector that is sector number 16. So all sectors except 0 and sector number 16 are not read using the key. Now in order to read sector 16, I have to use the same key that is used for the MAD sector. I'm going to authenticate sector 16, authenticate and read it. So the sector 16 has been read, and I'm also going to read the sector 0. So now we have read all the sectors of Mifare Classic 4K. Now the difference between the Classic 1K and 4K is the 4K, the structure, the MAD type for a 4K is called the MAD2, and in fact this byte is supposed to show a different value, but however I cannot see why it is still C1. So the first sector, sector 0, it's for the MAD0, and a similar structure is also present in sector 16. It's very obvious to have 2 MAD sectors because the Mifare Classic 4K has got more memory. The sector 0 or the MAD stored in sector 0 can address only the first 15 sectors, because if you count these pairs here, every sector requires 2 bytes of application ID. You can put only 15 of them here. The remaining, because we've got more memory in Mifare 4K, so this extension of the MAD that's stored in sector 0. However, the first 2 bytes here, they're still not used, so that's set to 00. So this will tell you that it's not it's a the second sector of the MAD2. Otherwise, everything is the same. So whenever you write any NDEF messages, you will see some data written here, like it was in Mifare Classic 1K. And if I make this as a read-only, you'll end up seeing all this, the read-only access rights. So literally, there's no difference between the MAD1 and the MAD2, except the MAD2 addresses more memory space, like a Mifare Classic 4K. I think that's all I got in this video. And so what we covered in this video is, so I showed you what the read-only does, and we also seen when you format a Mifare Classic 4K, it creates 2 MAD sectors. The first is in the sector 0, and the second part is in the sector 16. Okay, thanks for watching.